Okay, so differential equations, which of the following is the solution to the differential equation dy dx is 3y squared with the initial conditions of y 0 equals 3? So, if we separate these variables, what we'll see is that we have 1 over 3y squared dy and 1 dx. So the dx comes up here, and the y term there, you can leave the 1/3 wherever you want, I guess. You can bring that 3 down there, so it doesn't really matter actually. You could leave the 3 up here, and it could be 3 dx and just 1 over y squared. I think it should be the same, which, yeah, it doesn't really matter. But if we take the integral of both sides, so this 1/3 really can now come outside technically, so it's 1/3 outside of that now, so 1 over y squared. And is this a logarithmic situation or not? What do you think? Okay, 1 over x or 1 over y would be a ln, but now we have the 2 there, so remember the key is you want to use ln, right, when you have a variable to the power of 1 down there, because if you because this would be y to the negative 1. If you added 1, you'd have 0, right? You'd have y to the 0, and then you'd have to divide by 0. So that's no good. That's why you have to use ln here. But if there's a variable other than 1, then you can just treat it like a like this would be y to the negative 2. That's the same, you see? So now if you add 1 to this exponent and divide by that, so then it's y to the negative 1 divided by negative 1. You see, so then it's okay. So you don't have to do the ln here. So that's going to be negative y to the negative 1. Okay. And this is just going to be x, and then we're going to plus c. Okay, does that make sense? Everyone that asked? Okay. All right, so this is going to be a negative 1/3. Let's pull that out there so it's not too confusing. Okay. Now we do have initial conditions, so we'll plug x equals 0 in there, and we'll do y equals 3. And so this is going to be negative 1 over 3 times, this is 3 to the negative 1, so that's another 1 over 3 equals 0 plus c. So c is going to equal, looks like negative 1/9. Okay. Negative 1/9 there. Okay, so we're getting there. We're getting there. So we'll put c in there. So I've got negative 1/3 y 1 over y. Actually, let's just do negative 1 over 3y. Okay, that's what kind of this is. Equals x minus 1 over 9. And so then I want to isolate for y. So if I multiply everything by 3y and then divide everything by x minus 1 over 9. Got a negative 1 up there still. It's going to be 3y over here. X minus 1 over 9 down here. And then the 3, I'll divide everything by 3. So then I should have y equals negative 1, and down here this is going to be 3x minus 1/3. And to simplify that, you don't want a fraction inside of your answer. So this would be, I guess, times 3, that would be 9 over 3. So we have negative 1 on top. We have 9x minus 1 all over 3. And when you divide by a fraction, you flip and multiply, so that's the same as 3 over 9x minus 1, right? And then you have y equals negative 3 over 9x minus 1. And the other way you could write that would be 3 over 1 minus 9x if the negative was down on the bottom or whatever. So looks like either one of those two, which is back up now to our answers here. Oops. Disappear. So here's the answers right here, I guess, on the screen, but it's going to be C, 3 over 1 minus 9x. Didn't, yeah, so this one right here. Because what we got, again, this didn't copy, but initially y equals negative 3 over 9x minus 1. And if that's what you get and don't see it up there, then you have to consider, D is pretty close, but it hasn't got a negative. So if you brought that negative, instead of being up there, if you brought it down here, right, then that would be positive 3 over negative 9x plus 1, which is the same as 1 minus 9x. And that's what you see up there. Okay? Good? Yeah. Awesome. For you. So in order to check this, if the question is how do you check this, good question. If you took the derivative of your solution, right, you'd be thinking I should get this should be the derivative, but you get the derivative right here. This is the derivative that you get in terms of x. So can that derivative be written as 3 times my original function squared? And that's what we worked out here. So this 3 times the original function squared is actually the way it can be written. So where did the rest of that go? Oh, it disappeared on me again. So y, remember, is 3 over 1 minus 9x, right? So y prime is 3 times 3 over 1 minus 9x times 3 over 1 minus 9x, which is the same as 3 times y, or y prime is 3y squared. So it does check out. But the question gave us the differential, gave us the derivative in terms of the y. They didn't show us what y was because that's what we're trying to find. So that's why they didn't put the y. They just let it equal y instead of 3 over 1 minus 9x, because we might have been able to figure it out just from looking at it. Yeah. That make sense?
Yeah.
That's a great question. One I hadn't really thought about for a while. So, but yeah, if you can write it as 3y squared, given that you have your new particular equation, then that checks out.
That's good.
Whew, good one. Yeah, you don't have to prove that, but yeah, you don't have to check it. And I definitely don't take the time on the AP exam to check it. Yeah, I wouldn't do that on the AP exam. That is a waste of time. If you see the answer there, you're pretty confident about your process, I would say just go with it. I mean, that would be my advice, because the AP exam is a lot of questions for a very short amount of time. So you have to be on the ball, recognizing and doing the questions. You won't have a whole lot of time to be double checking things.
Yeah.
I mean, unless you're way quicker at than me, which some of you might be, but I wouldn't be showing my proof or checking every question. I'd be moving on. If you're confident with your work and you see your answer there, then yeah, I've just select it and move on. But yeah, that is how you would check. Good question. Yeah.